Hello, my name is TTJ Kepsi Richard and welcome to my online tutorials. Today, our discussion on numerical and computational method will be on finite difference. Before you can be able to understand finite difference very well, there is a need to know how to construct a difference table. So today in this video, we will learn how to construct a difference table and determine the type of function that connects two sets of values in a table. So this will be a very interesting engagement, so please come along. So as I said, we are starting with how to construct a difference table. And we'll look at our first example. Say construct a difference table for the set of values of x and y and determine the form of polynomial function connecting x and y in the table below. So, and the table is given like this. The set of values for x are 1, 2, 3, 4, 5, 6. And that of y is 9, 15, 23, 33, 45, 59. So, when we are constructing a difference table, the type or the difference in which we reach and we get constants will help us determine the type of polynomial function that connects the x to the y. So, let's learn how to put this into practice. So in order to construct a difference table, there is a need to draw a table of this nature. So you construct it, write the set of values for x here and y here. Leave these spaces in order to write the differences. So the first difference of y, we are going to find only the difference for the y. So the first difference for y is known as delta y, will be 15 minus 9. And 15 minus 9 is 6. Then we write it here. Now we'll find the difference between 50 and 23. That means 23 minus 15, and that will be 8. The second difference, the next one, 33 minus 23, that will be 10. Then 45 minus 33, that will be 12. Then 59 minus 45, that will be 40. I hope you get that. Then you see that all these are not constant, or they are not the same. Then we'll find the second difference, known as del square y. So the second difference, 8 minus 6, that will be 2. 10 minus 8, that will be 2. 12 minus 10, that will be 2. 40 minus 12, that will be 2. So you see that the difference or the second difference are all constant, or they are all 2. Then there is no need to go beyond the second difference. If you go beyond the second difference, that means every difference you get there will be 0. So since the second difference is constant, that means the polynomial function connecting x and y is of degree 2, is of second degree. As far as the second degree or the second difference of our difference table is constant, then the polynomial function that connects x to y or y to x is of degree 2. So we say that, therefore, the polynomial function connecting x and y is of degree 2. And it will be in the form y is equal to a second degree polynomial, that's ax squared plus bs plus c. I hope you get that. We'll solve another example where we learn how to construct a difference table for a set of values where a function connects those two values. So let's look at our second example. They say construct a difference table for the set of values of x and y and determine the form of polynomial function connecting x and y in the table below. And the set of values for the x is -1, 1, 3, 5, 7. And that of the y is 1, 9, 1, -23, -63. So how do we do that? So we draw a table of this nature, as we did for the first example, leaving space to write the differences. So we'll find only the difference for the y, the difference between the y values. So the first difference, known as delta y, will be 9 minus 1, which is 8. Then 1 minus 9 will be -8. Negative 23 minus 1, that will be -24. Then negative 63 minus negative 23. So that will be negative 63 minus negative 23. That's negative 63 plus 23. And that will be negative 40. So we write our negative, we write a negative 40 here. So since the first difference does not give us the same values or constant, we find the second difference, which is del square y, the second difference. So we subtract this from this, negative 8 minus 8, that will be negative 16. Then negative 24 minus negative 8, that will be negative 24 plus 8, and that will be negative 16 as well. Then negative 40 minus negative 24 will be negative 16 as well. So since the second difference are all the same or they are constant, then this polynomial is of degree 2. So we say that the polynomial that connects x and y is of degree 2. And is in the form y equal to ax squared plus bx plus c. I hope you get that. So if it go beyond, if the constant go beyond the second difference or maybe third difference, then it's of degree 3 in that order. So our understanding in the construction of a difference table will help us understand the final difference as a topic very well. So we'll solve another example on it. If you construct a difference table for the set of values of x and y and determine the form of polynomial function connecting x and y in the table below. And that set of values for x are 1, 3, 5, 7, 9, and 11. And their corresponding values of y are negative 4, negative 92, negative 396, negative 1060, negative 2228, and negative 4044. So how do we do that? So we just construct a table of this form. We list the x values and leaving spaces in order to write the differences there. So we find the first difference of y. So we said del y. And how do we get that? We subtract negative 4 from negative 92. When we do that, that will be negative 92 minus negative 4. That will be negative 92 plus 4. When we do that very well, that will be negative 88. We'll do the same to this. Negative 396 minus negative 92 will get negative 304. Then we subtract negative 396 from negative 1060. We'll get negative 664. The same way, we subtract negative 1060 from negative 2228. We'll get negative 1168. The same way, we subtract negative 2228 from negative 4044. We'll get negative 1816. I hope you get that. So since the first difference is not constant or they are not the same, we go further to find the second difference. So we'll go further to find the second difference, known as del square y. That means we subtract negative 88 from negative 304. If you do that very well, you get negative 216. Again, we subtract negative 304 from negative 664. We'll get negative 360. The same way we subtract negative 664 from 1168. We'll get negative 504. Again, we subtract negative 1160 from negative 1816. We'll get negative 648. So we can see that the second difference are also not the same. We go further to find the third difference. So let's go further to find our third difference. That's del quip y. And see, so we'll find the difference between this and this. That's negative 360 minus negative 216. We'll get negative 144. Then negative 504 minus negative 360. Still get negative 144. Then negative 648 minus negative 504 will be negative 144. So since these are the same, you see that our polynomial function is of degree 3. So we say that the polynomial function is of degree 3 and is in the form y is equal to ax cubed plus bx squared plus cx plus d, where a, b, c, and d are all constants. I hope you get that. We'll solve one last small questions on how to construct difference table, and we take it from there. So look at our fourth example. Please, you can pause the video and try solving. After that, you compare your answers with mine. They say construct a difference table for the set of values of x and y and determine the form of polynomial function connecting x and y in the table below. And the x values ranging from 0, 2, 4, 6, 8 to 10. Then the y values 7, 13, 43, 145, 367, and 757. So how do we do that? So I told you just have to construct a table of this nature, leaving space in between them to write the difference. So we'll find our first difference of y, which is delta y. 13 minus 7, that will be 6. 43 minus 13, that's 30. 145 minus 43, that will give us 102. Then 367 minus 145, that will give us 222. Then 757 minus 367, that will give us 390. So you can see that the first difference does not produce a constant, or they are not the same. So we'll find the second difference. So the second difference, which is del square y, will be 30 minus this 6, that will be 24. Then 102 minus 30, that will be 72. Then 222 minus 102, that will be 120. Then 390 minus 222, that will be 168. So you can see that the second difference too does not produce a constant. So we find the third difference, which is del quip y. So with the third difference, 72 minus 24, that will give us 48. 120 minus 72, that will give us 48. 168 minus 120, that will give us 48. So you can see that they are now constant. So our polynomial function is of degree 3. So we say that the polynomial function is of degree 3 and is in the form y equal to ax cubed plus bx squared plus cx plus d. I hope you get that. We'll end it here today. We learn how to construct difference table today. Our idea in the construction of difference table will help us understand our final difference. Please check out my videos on how to find, since we say that the function connecting x and y is in the form ax cubed plus bx plus ax cubed plus bx squared plus cx plus d, and whilst a, b, c, and d are constant, how do we find the function? So check out my videos on that. Until we meet again, remember to subscribe to my YouTube channel. My name is Kepsi.